I'm Peter Townshend, qualified civil engineer. I graduated in 1969 from the University of Natal. Most of my life has been spent with consulting engineers, doing a variety of work, a broad-based experience from civil and structural work. But more recently, over the last 20-25 years, I've had an interest and a passion for water and for water control. And through that passion, we've sort of developed a range of automatic water control equipment, which is unique in the world and developed in this country. Well, Johan, that's a very controversial subject because we are in a state of crisis, impending crisis, and it's only recently that the government and the public have realized this and are taking steps to it. Generally, I could refer to our water condition as the 3 Ks, being these are phonetical Ks: quality, quantity, and consumption are the 3 main areas that we need to focus on, and areas that we have crisis in this country. South Africa is not really a water-rich country. We have an average rainfall of less than 500 millimeters across the country, and the water that we do have is usually in areas where we don't need it, and vice versa. So consequently, we are a country which has diverse rainfall going from west to east and to the coast, and we find that the rainfall that we need in areas of the dense industrial areas where the demand is the highest is usually where we don't have sufficient water. There's an increasing demand in South Africa for water. This is obviously due to increased population over the years, and the government's policy, correctly, is to try and provide clean, safe water to all the inhabitants of this country. That's going to be a large demand on our water resources. Then, in addition to that, there's an increased standard of living, and with that comes an increased water usage. From the very rural people who have to go and fetch their water from the local stream, they are probably the most efficient water users, to the affluent environments that we have in urban areas where water can be irrigating on the lawns day and night. So with the increase in wealth and living conditions goes the increase in water consumption. In addition to that, our industrial and mining industry is increasing, and that consumes a considerable amount of water. And then food production. About 60 to 70% of our water is used on irrigation, and that needs to be done to feed an increasing population. So our demand is increasing all the time, and in order to meet this demand in South Africa, our authorities need to look at a variety of mechanisms. One is to build more dams. It's not always possible to build dams where they're needed because of the water resources, but there are a number of dams that are being planned and are under construction, like the De Hoop Dam in the Limpopo province. Then there are interbasin transfers, such as from Lesotho into South Africa, which is also a cross-border utilization of water. And then more recently, and more importantly because it's needed, is desalination, where we will be looking at winning fresh water or potable water from the sea. All these mechanisms will come into play, but they are expensive. there is a price to pay for water. If you don't have water, you have to pay for it. Yes, there are figures that have been banded about, ranging from 2 to 5 rand a cubic meter, depending on the size of the desalination plant. It is very energy consumptive, although the more recent technology of reverse osmosis does have a recovery of energy. But nevertheless, it is a costly exercise. It is a costly process to get water from the sea, more so than water from dams and from rivers. What skews the public perception at the moment is up here in Gauteng area and the Highveld area. We've had good rains this year, extremely good rains. And it's very hard for people to imagine that we're going to have a water shortage. However, in the Eastern Cape, Port Elizabeth area, they are in the grips of a dry period. Their municipal dams are only sitting just over a third full, when they should be substantially fuller than that. And so that is the problem in this country, that we have this difference of in areas, some very wet, some very dry. In this area, which is the hub of the industrial area of South Africa, it is predicted that we are running into a problem in that we are already exceeding the capacity of the Vaal River system. And the phase 2 of Lesotho, which is scheduled for 9, maybe 10 years' time, will deliver more water. But in the interim, it's very possible that we will run short of water. So consequently, the focus has to move onto how to reuse wastewater, how to save water, and to how to plug our losses as much as possible. But generally, it's accepted that maybe 15 to 20 years' time, we could be short of water in this country. And we may have to look north to our northern countries where they will get more water. As far as global warming is concerned, the pundits, the climatologists, are predicting that we get less rain for areas south of the Zambezi and more rain for the areas north of that. And already there are indications in some of the rainfall and runoff figures over a long period of time that we are getting less rain, and in addition to that, more severe rainstorms. So the intensity of the rains are increasing, and with it come other problems associated with runoff and floods, etc. The quality is constantly deteriorating, and there are essentially 3 sources or 4 sources that contribute to that. The one that is most topical at the moment is acid mine drainage, which we can talk about a little later. The other is the uncontrolled and unpoliced discharge by industry and mines into the watercourses. And this is basically due to a lack of adequate policing, which the Department of Water Affairs admit that you don't have enough people to police these discharges. And then the other one is informal squatter settlements, which naturally sort of set themselves up near watercourses because that's where their water comes from. And with that, their waste and refuse and debris ends up in the watercourse, all adding to the deterioration of the water quality. And obviously, as we see blocked sewers, overflowing sewers running down the roads into the stormwater system and into the watercourses and our rivers. So all that adds to the fact that our water quality is deteriorating and is beginning to have adverse effects not only on human health, which is probably the primary one, but also on industry. A lot of the rivers serve as the main source for irrigation, for edible crops or for deciduous fruit, and the fact that we may be using polluted water could actually jeopardize our overseas markets. It has been said that could be a case, especially in the Western Cape. So consequently, water quality is a major issue, and we need to look at it. We have a lot of smaller municipalities who are not able to adequately treat their sewage. Either from a lack of technical skills or whatever, they don't have the ability to maintain the treatment works in the state they should do, and a lot of partially or even raw sewage is discharged into the watercourses. Like there is for the energy crisis, we see it on TVs, there's more of an awareness of it, but there's not that level of awareness being brought to the public for polluting. There's still a lot of litter which has just been strewn around the streets, which end up in the watercourses, which biodegrade, and they add to the nutrient load in it. And Hartbeespoort Dam is an example of maybe the biggest maturation pond in the world. So that's one aspect. But the other engineering solution that we may go for is to try and remove the mechanically operated sewage plants and go for a more natural type of treatment, such as reed beds, which work very well at treating the water to the standard where they can be released into the watercourses. It's a non-mechanical process, and I believe it has a lot of potential in this country. However, we need to get the municipality's mindset along the lines of just using a natural way of treating sewage. Now, it's general knowledge that the municipalities have losses which may vary from as little as 25% up to 60 or 70% or higher. Some of them don't even know what their losses are. And this is valuable water which is just being returned to the watercourses and is being lost. So we need to recover and reduce those losses. If we were able to just reduce losses in the Gauteng area, we may be able to span the time span before phase 2 of Gauteng, of the Lesotho Highlands Water Scheme comes into operation. So we need to spend a lot of money on it, and already the Gauteng government is spending, or provincial government will be spending more than 50 to 100 million rand on improving existing infrastructure, water supply. The losses can be attributed to old pipes and valve systems in the cities. A lot of them are buried under major roads and in CBD areas which are difficult to get to. It's not an easy thing to replace those. In addition, the pipe network systems, some of them operate under unnecessarily high pressures, and even a pinprick of a leak under high pressure will lose water. Whereas if you can reduce that pressure by a few bars, that leak will reduce substantially. So pressure management is also important. There are companies that monitor this, and they're doing a good job at reducing the losses in these municipalities. And then the other problem is insufficient skills and resources to react quickly to a burst pipe. And the public are urged to contact the municipality as soon as they see a leak occurring or a burst pipe. Overflowing reservoirs is another area of loss, where the valves, the control valves, are not functioning properly. And then the old problem of illegal connections to get water for free. As it has been a problem for electricity, so it is with water. There are a lot of illegal connections. And even the municipality of Durban is even offering a period of grace for people to come clean on their water, because they will be found out and they will be penalized. So they need to be reduced as well, because that's an under-recovery of costs, of the expenses. And without those recoveries, those people who are paying will be paying more for water. As far as I'm aware, Johan, there's no legislation other than polluting, but there's no legislation against the uses of water or unnecessary or excessive use of water. That's for private people. The other loss that we do have is unregistered irrigators who pump water out of the rivers. There's legislation against that under the Water Act as well. But the main regulator of water would be cost, unfortunately. However, if it gets to a crisis, I mean, there are other mechanical ways of doing it, by putting a restrictor, an orifice plate into the supply to a private property, which will reduce their pressure and the water usage will drop significantly. I think it's against the Constitution to close off water completely. It's needed for health and to sustain life, but you can reduce it to a trickle. And that is the one mechanism that can happen if we find that the people are being abusive with water usage or don't pay their accounts. Because of our sort of impending crisis for water supply, water demand, we as the public should take certain measures to reduce our consumption or reuse water as much as possible. Rain harvesting, which is becoming more fashionable now, which is essentially just the storage of rainwater, is an effective way of doing it, and more companies, new buildings that are going up, green buildings, incorporate the principle of rain harvesting. On private properties, we should try and harvest as much of the runoff from our roofs as possible. The other is to use grey water from the bath or the wash hand basin, and either store it or lead it directly onto your lawn or garden as a water saving measure. There are some companies which collect that, can treat it slightly and put it back into the cisterns, so that becomes the flushing water for the toilets. We need to get away from this practice of washing down driveways, hard stand areas. It's an easy way of doing it, but it's wasting water. We need to do it the hard way and sweep it out. We are quite extravagant the way we use good, fresh, clean water to irrigate our lawns and so on. And there are a number of ingenious methods going out at the moment, even planting gardens with drier species of things, more indigenous plants which take less water. There are a lot of those around as well, but we need to be aware of the value of water and start reducing that. Well, to build a new dam is both costly, it takes time, very time consuming, but probably more so, it's very it has a lot of environmental problems associated with it. It's probably easier to raise a dam by a couple of meters to win between 15 or maybe even 50% extra capacity in the dam, and if you do that to 3 or 4 dams, it's effectively the same as building one new dam. And a lot of our dams The majority of our dams in this country are probably more than 40 to 50 years old, or even older, and they have accumulated sediment. On average, about 25 to 30% of our total storage capacity has been lost to sediment. And so that is an additional loss on our water supply. And just to compensate for the loss in storage due to sedimentation, we should look at raising our dams. In addition to raising an existing dam conventionally, I call it conventionally, there are environmental issues because you invariably require considerable quantities of fill, and that means quarrying, it means increased transport, and the environmentalists always find a way of increasing the negative impact of doing such a thing. Whereas installing gates, the gates are manufactured in a controlled environment, in a workshop, with quality control, and the site involvement is purely one of installing them on the dam. The environmental impact is minimal compared to conventional raising. However, I do re-stress that if you can get away with increasing the capacity with an ungated spillway in this country, we should do it. The main reason why there has been somewhat of an adverse tendency to go for gates on spillways is because traditionally the spillways have utilized electrically or mechanically driven gates. Most of them are the radial gates, but there are also vertical roller gates. And some of these are stuck, they're just not working anymore. And that can be put down to a number of reasons: corrosion, but generally lack of maintenance. And because of that, these gates, when they're required to work, don't work. They're either stuck or they just don't work. They haven't been maintained. So the safer way is to try and build a dam without gates. However, there is a new generation of gates which are automatic, which don't require any electrical or mechanical input. And where the dam conditions sort of dictate that a gate's required, we should look at automatic gates because it eliminates some of the problems associated with electrically driven gates.
Fully tested by independent universities, our TOPS gate offers a quick and affordable solution to increasing water level in dams, from as little as 0.75 meters to a whopping 6 meters. The gate will open automatically as the water level rises in the dam when a flood passes through it, and will close again automatically once the flood has passed, retaining the increased water level. Easy, straightforward and uncomplicated. That's the flow gate solution. The gate is closed while the water level in the dam is rising. Note that the water level in the ballast tank rises as well. The weight of the ballast tank will ensure that the gate remains closed right up to the full supply level of the dam. Should the water level rise above increased full supply level, water will overflow to the front closure plate while the gate remains closed. As the upstream water level rises even higher, the gate rotates upwards to pass the flood water. As the flood recedes, the gate rotates back to its fully closed position, with the dam now filled to its new enlarged capacity provided by the celebrated TOPS automatic spillway gate. This gate is installed on the crest of a weir or dam to implement storage and flood control. It provides an economical increase in storage capacity without raising the dam wall and without increasing the maximum permissible flood level. Debris control, screening and scouring are all effectively and efficiently handled. Under normal conditions, the buoyancy tank acts as the gate, which retains the increased water level. With floodwater rising and inflow into the weir, the weight of water will rotate the crest gate downward to allow an uncontrolled flow over the spillway. During peak flood conditions, the crest gate will automatically move to its fully submerged position to allow maximum flow from the spillway. Finally, as the flood recedes, the buoyancy tank will empty and the gate will float at its closed position to retain the increased supply level. Our scour gate is installed in the lower levels of a weir or dam to provide scouring, flood control and water regulation. In a canal system, it will ensure automatic rejection of excess flow as well as sediment. Designed to control a constant but adjustable downstream water level with a widely varying level upstream, this automatic diaphragm valve has a proven accuracy of control better than required in normal practice. The valve can be used in diversion works, reservoir inlets, river offtakes, dam outlets and canals for water apportionment in standard upstream variations from 0.3 meters to 40 meters. It can be manually operated and locked to prevent tampering by unauthorized persons.
As far as the history of the gates and the water control equipment is concerned, this can all be attributed to Mr. Laurie Turner, who back in the 1960s, a farmer in the Eastern Cape, a very innovative man, had the Orange River fish canal system flowing through his farm and wanted to irrigate from it. But he realized that the water needs to be controlled and made inquiries with the Department of Water Affairs as to what equipment they used, which at that stage was purely manual slide gates. He researched overseas equipment. There is some French products which he looked at and thought he could do better. And consequently, with some introduction from an overseas person in America, was able to develop the diaphragm valve. Further than that, the weir across the Little Fish River would silt up, and did silt up into the canal, the offtake canal, to the point where it was actually jeopardizing the whole irrigation scheme. And he then consequently came up with the Scour Gate and the Crest Gates. So all these gates have been developed in South Africa by a person with no technical, but just very practical person. That technology was then handed over to engineers, and myself, together with Brian Middleton, were one of the earlier pioneers of the equipment. This goes back to the 1960s. The first regulating gate in Potensi on the Gamtoos irrigation scheme was installed in 1967, so you can see it goes back a long time, and it's still working today. It's only been taken out once for a recoating, but it's still working perfectly well. And we've just added a bit more engineering to it, but the concept is simple. It's designed for African conditions, where it can stay in a remote area. It can handle the climatic conditions, the floods, the hot weather, and the debris. A feature of this equipment is that the equipment has been designed to handle the debris loads that we get in our rivers and irrigation schemes, and the dirty water. And so consequently, it's designed for Africa, but the technology has found a lot of interest in other parts of the world as well for irrigation schemes. And we now are looking, and we have equipment installed in Africa, in Uganda, Zambia, Zimbabwe, Swaziland, Namibia, and more recently Peru, as well as Crest Gates in Australia. So the equipment has found a considerable amount of interest around the world.